Hello, so we're looking at the unit circle and how it can extend our definition of trig functions. So what we know about trigonometry is that we can use this little acronym, SOHCAHTOA, to help us calculate the lengths and missing angles in right-angled triangles, but it only works when our reference angle is greater than 0 and less than 90. Okay, so it has limitations. So what we're looking at today is we're using the unit circle to help extend our definition of the trig functions. So first thing we need to do with our unit circle is label the axes. So this is X, this is Y, and then let's label some coordinates. So unit circle, meaning it has a radius of 1, so therefore the coordinates at this point would be 1, 0. Oh, I didn't draw that very well. Let me do it again. 1, 0. Up here, the coordinates would be 0, 1. Over here, coordinates are negative 1, 0. And down here, we have the coordinate of 0, negative 1. Now, we're going to draw an angle. So we're going to start with the initial side of the angle out here on the positive x-axis. So when we're drawing angles, we always start from this point on the unit circle, and then we move in an anti-clockwise direction this way to get a positive angle. So if I now draw in the terminal side of that angle, and then we've got our angle theta in here, which is going in that direction. It's a positive angle. Let me delete that. All right, so now let's mark this point where the terminal side of our angle intersects with the unit circle. Now, if I turn this into a right-angled triangle, we can use what we already know about trigonometry and SOHCAHTOA to help extend our understanding. So, first of all, let's label this coordinates as A, B. A is our x coordinate, B is our y coordinate. So first of all, if I want to get the length of this side here, so this side here, well, I can actually see that it actually is the same length of wherever it intersects with, I didn't draw that very straight, did I? Try that again. It's going to be the same length as where it intersects with the y-axis. So this side of the triangle here is actually the same as our y-coordinate. So we can call this B, all right, which is our y-coordinate up here. Now, the same can be said down here. If just going to use a different colour. If I look at the length of this side of the triangle, you see it's going to be the same as the x-coordinate up here. All right, so that actually is going to be A. Now, what does that mean? Let's have a look at the sine. So let's use the trig that we already know. We know that the sine of theta is equal to the opposite over the hypotenuse. So if we go back to our triangle we've just drawn here, let me delete these lines just to make it a bit clearer. We can see, we know the hypotenuse. The hypotenuse is the radius of this circle, and we know that the radius of this circle is 1. So we know that the hypotenuse is going to be 1. Now the opposite side of our reference angle is B. So that means the sine of theta is equal to B, which is our y-coordinate. All right. Now, we can also use cosine. Let's have a look at cosine. So cosine is the adjacent over the hypotenuse. So again, the hypotenuse we know is 1. And the adjacent side is A. And A divided by 1, of course, is A. So again, cosine of theta is equal to A, which is our x-coordinate. All right, so we have the sine of theta is equal to B. Terrible writing. is equal to B, and we have the cosine of theta is equal to A. So if I go back to our coordinates here, let's have a look at them, pull it down here. Our coordinate where that terminal side of the angle intersected with the unit circle was AB, which I can now call cosine theta, comma, sine of theta. Now we can also look at tan here. Let's have a look at tan. So the tan of theta is equal to the opposite over adjacent. Now if we go back and have a look, the opposite side of that reference angle is B and the adjacent side is A. So we can say that that is the same as B over A. And if we go back over, we can see that B is equal to the sine of theta and cosine, and A is equal to the cosine of theta. Therefore, tan is equal to the sine of theta divided by the cosine of theta. So let me just write that underneath for you. So the tan of theta is equal to the sine of theta divided by the cosine of theta. And we will leave it there.